The distance between C and D is 13. C is negative 3, 8, and D is 9, comma, y. Solve for y. Okay, so we're going to start by using the distance formula because we see the word distance, right? So we know we're going to use the distance formula. Now, this one's unique because they're actually giving us the distance. They are telling us the distance is 13. So this is kind of like Jeopardy. We already know the answer, and we're trying to find like the question, right? So 13 equals, we're going to do our skeleton, minus, minus, plus, squared, squared. Remember, distance formula is really just Pythagorean theorem, a squared plus b squared, where a is the change in x and b is the change in y. Okay? Circle our x's and underline our y's. We put the circles together and the underlines together, but on purpose, I'm going to put 9 and then negative 3. I'm going to put y and then 8. So I started with the second one on purpose. Okay? Now we're going to start to clean this up a little bit. 13 equals the square root of 12 squared, right? 144 plus y minus 8 squared. We're trying to solve for y. We're trying to get y all alone. So that means we need to undo what's being done to it. We need to undo it. How do you undo square rooting something? How do you undo square rooting something? Square it. Thank you, Rishi. So we are going to square it. Whatever you do to one side, you must also do to the other side, right? So we are going to square the right, and the squared and the square root will cancel. And we're going to square the left, and we're going to get 169. So 169 equals, we're going to write what was under the radical, and we're not going to change it at all. Do you notice how I didn't touch what was under the radical? It is preserved. Nothing changed. All that happened was the square root and the squared canceled each other out. I didn't square anything under the radical. You got this far? Good. So we're still solving for y. We're still doing the opposite of what's being done to it. So the opposite of positive 144 is negative 144. So you subtract 144, and you get 25 equals y minus 8 squared. Now we're still doing the opposite of what's being done to y. The opposite of squaring something is square rooting. So to get rid of that squared, you square root. And whatever you do to one side, you must also do to the other. Now when you square root two sides of an equation, you get plus or minus in your answer. So the square root of 25 is not 5, it's plus or minus 5. And that's going to equal y minus 8. The squared and the square root cancel, and you're left with y minus 8. So then what you do is you can set them up separately. You can say, hey, 5 equals y minus 8, and negative 5 equals y minus 8. Then you add 8 to both sides. Y is 13. And you add 8 to both sides, and y is 3. So the answer is 13 and 3. It's kind of neat to see why there's two answers if you look at it kind of in the scale of a graph. So C is negative 3, 8, and D is 9, comma, y. So C is negative 3, 8. And D is 9, comma, y. We don't know what y is. So it's somewhere on that dotted line. We know that the distance is 13. So we need to go 13, and we could go 13 this way and land at 3. Or we could hit the line by going 13 this way and land at 13. Do you see why there's two answers? The other end point lies somewhere on the dotted line, and to travel a distance of 13, you can kind of head up this way or head down this way. You can go below or above. So that is why there are two y answers. Okay, I'm going to give you another one just like that and see if you can do it on your own this time. So, same problem, but Miss Tanton changed up the numbers, another try, and see if you'll be ready to solve this on your quiz tomorrow. Okay? Try this one, please. I'm gonna start setting it up for you. Just to make sure that if you're having trouble, you didn't get stuck along the way. Circle, circle, underline, underline. I'm choosing this point first on purpose. 20 minus 2 and y minus negative 7. And then you start to clean it up. 30 equals the square root of, let's see, 18 squared. I should know that one. 324. And then you need to start undoing things. The opposite of square rooting is squaring. Then you write what's underneath the radical, and you write it exactly how it looked before. You do not touch what was under the radical. You don't square anything. You do not touch what was under the radical. And then you subtract. So 900 minus 324, 576. And then to undo squaring, you square root. Whatever you do to one side, you must also do to the other. We are very glad that it's a perfect square, right? The square root of 576 is plus or minus 24. The squared and the square root cancel. So you've got your y plus 7. And then you set it up separately. 24 equals y plus 7. Negative 24 equals y plus 7. And then you subtract 7 from both sides. So what are we getting as our answers? (24 minus 7) and negative 24 minus 7. So you should get 17 and negative 31. Very good. Y equals 17 and negative 31. Okay. Yay, I'm glad you get it. Let's move on to today's lesson. We're going to skip these slides because that's what we're going to play at the end of class if we have time. Okay. Here are the answers to your homework. Yesterday we learned nth term, linear, and quadratic. Today we're going to add on to that. We're going to learn quadratic with a middle term, and we're going to learn exponential. You checking your homework? So today we're going to move on, and we're going to talk about, like I said, quadratic with a middle term, because yesterday none of our quadratics had a middle term, and then exponential. What is true about an exponential if you look at that parent function? So an exponential, the base right here, the base is going to be an integer. Oh, what did you want to say? Like y equals 3 to the x. The base is going to be a number instead of being x. Whereas a quadratic is y equals x squared. An exponential would be like y equals 3 to the x. All right, on this one, you just have to get some notes out, and you are going to have to draw your own tables today. I know yesterday we were doing problems from your homework, but today these problems you're just going to have to sketch them down somewhere, okay? All right. This one is going to be different because it's quadratic with a middle term. This one's going to be a little bit tougher, and there's going to be more steps to remember. But if you can follow along and you can practice at home, then you're going to be fine, okay? We always start by doing delta y. That is what we start with all the time, every time. So we're always subtracting. 13 minus 5 is 8. 25 minus 13 is 12. 41 minus 25 is 16. 61 minus 41 is 20. When delta y is not constant, we immediately know, hey, this is not a linear pattern. This is not a linear equation. So now we know that we need to do delta delta y. Delta delta y. And so we do 12 minus 8 and 16 minus 12 and 20 minus 16, and we get 4, 4, 4. Now, since it's a quadratic, we're still going to do the 2, 2 rule. We're still going to take 4, we're going to divide it by 2, and that is still our coefficient. So nothing has changed so far. You still square the term. Oops. That was a horrible 2. Okay, so the next thing that we do is, since I already know this is one with a middle term, I'm going to go ahead and just show you what you would do next. And then we'll talk about how you tell whether it's going to have a middle term or not. What you do next is, yes, Abby, yes, when it's delta delta y, you know it's quadratic, and so you square it. The next thing you do is see, what do I have, and what do I need to do to make it look like 5? So 2 times 1 squared is 2. How do you make 2 look like 5? And you're going to make a little note. Plus 3. 2 times 2 squared, that's 2 times 4. That is 8. How do you make 8 look like 13? Plus 5. 3 squared is 9. 9 times 2 is 18. How do you make 18 look like 25? Plus 7. You see what's happening? What's supposed to be constant is not constant. It's changing. Yesterday, that number was the same every time. So, to find that middle term, to find the coefficient of the middle term, you find the difference in that little note that you made. The difference. How do you get from 3 to 5? Plus 2. How do you get from 5 to 7? Plus 2. So on and so forth. So 2 is actually your middle term. It's just a coincidence that it's the same as your coefficient. Now our middle term is just x. So you just write 1, 2, 3, 4, 5, 20, n. There we go. 2n squared plus 2n. That's what we have so far. 2n squared plus 2n. Now we need to say, take inventory. How much do we have and how much do we need? And this one should be constant. Yes, Johan? So 2 times 1 squared is 2. 2 plus 2 is 4. How do you make 4 look like 5? Let's see, 2 times 2 squared, that's 8. 8 plus 4 is 12. How do you make 12 look like 13? And now you're done. That was a weird plus. So our answer to the problem on this one is 2n squared plus 2n plus 1. And our 20th term, let's see, 2 times 20 squared plus 2 times 20 plus 1. Whoa, that was a lot of zeros. Okay. 841. Very good. All right, let's try another one. Same way we start off every time. Six. So delta y is not constant. So we do delta delta y, we get 6, and therefore our coefficient is 3. Very good. Our coefficient is 3. And then we square our term because we know it is quadratic. By the way, on a quiz, all I'm going to ask you for is the 20th term and the nth term. So you don't have to show all your work in the process columns if you are able to find the answer without showing all your work. So you do not have to do that. All right, the next thing what we do is find out what we have and what we need it to look like. 3. How do you make 3 look like 4? plus 1. 3 times 2 squared. So 3 times 4 is 12. How do you make 12 look like 12? Plus 0. 3 squared is 9. 9 times 3 is 27. How do you make 27 look like 26? Do you see the pattern? So what is happening between 1 and 0? 0 and negative 1. Negative 1 and negative 2. Yes, very good. Our middle term is negative 1. That is the change in my red notes. That's the change. It's negative 1. And since it's our middle term, we don't square it. We just put the number. All right, and now as the last step, you take inventory. What do I have and what do I need? So 3 times 1 squared is 3. 3 minus 1 is 2. How do you make 2 look like 4? Plus 2. Check it twice, just like Santa. Let's see, 12 minus 1 is 11. How do you make 11? No, 12 minus... Sorry. Yes, so you got 12 minus 2, and that is 10. How do you make 10 look like 12? All right. Plus 2, all the way down the row. So our equation is 3n squared minus n plus 2. Remember, you don't need to write the 1. The 1 is understood. And now we're going to try the 20th term. 3 times 20 squared minus 20 plus 2. What are y'all getting? Yep, good job, Chloe. 1,182. So that is quadratic with a middle term. You definitely need to practice that in your homework tonight. Who's ever heard of this triangle? Have you seen this pattern before? It's called Sierpinski's triangle. Yep. It's not called the Triforce. It's called Sierpinski's triangle. Maybe. I don't know. So we're going to try to find out how many triangles would be at stage N. Like if I wanted to know how many triangles were at stage 30 or stage 11, I need to have a rule. I need to have an equation. So what we're doing here is we're counting the number of dark triangles in each one. Okay? So if someone gave you this problem, you would need to be organized. You would need to take your data and put it into a table so that you can find a pattern. So how would you find how many triangles are at step N? Remember, we're only counting the dark triangles. The shaded triangles are the ones we're looking at. The other ones that are not shaded are not part of Sierpinski's triangle. So what you would do if someone asked you this problem is you would organize yourself. You would say, hey, in the first step, there's 3 shaded triangles. In the second step, I counted 9. In the third step, I counted 27. In the fourth step, I counted 81. You would organize your data. And then you would say, I need to figure out a pattern. Okay, you already know the answer. But what you would do first is you would do delta y. And you would realize that it's not constant, right? 9 minus 3, 27 minus 9. So we've got 6, we've got 18. 81 minus 27, 54. So then, as usual, you do delta y, and you realize that we're in trouble. We're in trouble because delta y is supposed to be constant, and it's not constant. So we now know that this is not linear, and this is not quadratic. And in this class, our only option, if it's not linear and not quadratic, is that it's exponential. So this one is exponential, okay? Now, what you can do, let's see, to kind of give you a hint when it is exponential, you can take your delta y and you can divide those numbers. What's 36 divided by 12? 3, okay? And so that is going to be your base. So this is 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5, 3 to the 6, and 3 to the n. And then you do your tweaking process if necessary. How do you make 3 look like 3? Plus 0. How do you make 3 squared? How do you make 9 look like 9? Plus 0. So we're actually done for this problem. So how many triangles would be in step 5? 243. And how many triangles would be in step 6? 729. That is exponential. Okay, let's try another one. Nth term exponential. Now, when I give these to you on a quiz, I'm not going to label it. I'm not going to say, hey guys, this one is exponential. So you're still going to have to start by doing delta y, okay? So you're just doing lots of subtracting. No good, so you do delta y. And we realize delta y is not constant. So we realize that this is exponential. And then I gave you a hint. I said, if you're trying to find your base of the exponential, sometimes it works where you can divide your delta y's. So you can do 144 divided by 36. The only time that's not going to work, I'll tell you later. 42 is the answer to the ultimate question. Is that from the movie? Okay. Yeah, 4. So is 4 our base? We're going to find out. We're going to try it. Let's see if it works. 4 to the 1 is 4. How do you make 4 look like 5? Plus 1. 4 to the 2 is 16. How do you make 16 look like 17? Plus 1. And then 64 plus 1. So that one's not bad. Your exponential is never going to have a middle term. It's always going to be your number to a power and then a constant. So you're never going to have to worry about anything messy with that, okay? All right, so we need to find the 5th term, the 6th term, and the nth term. The nth term is 4 to the n plus 1. This one's going to be 4 to the 5th plus 1, 4 to the 6th plus 1. Do you see how fast exponential grows? It grows really, really, really fast. 1,025 and 4,097. Nice. 4 to the n plus 1 is the answer. 4 to the n plus 1. All right, last problem. Another real-world problem. Jenny decided to create a website to promote her Halloween costume-making business. Okay, so she's going to promote her Halloween costume-making business. After the first day of launching her website, she saw it only had 1 hit. Oh, man. So first day, 1 hit. The next day, she told her family about it, and she had 7 hits. The third day, she told her friends about it, and she had 25 hits. The 4th day, she posted to Facebook and got 79 hits. Now, if her growth continues on her website, how many hits will she have? ... after 10 days. So see if you can find out what the pattern is on this one. So you can tell that this one, again, is going to be exponential because our delta y was not constant. Now, like I said, you can get a clue about your base, what number is your base, by dividing your delta y's. 36 divided by 12. We've had this base before. It is 3. 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. And how do you make 3 look like 1? Minus 2. How do you make 9 look like 7? Minus 2, minus 2, minus 2. So how many hits will she have after 10 days? A lot of hits. 3 to the 10 minus 2. Yeah. 59,047. That's a lot of growth. This is kind of unrealistic. Okay, before I close out this lesson, I do just want to show you all your options. Now, the ones we worked in class all looked like this. They all looked like this. So we didn't actually do any of the really tough ones. Those are on your homework tonight. Well, actually, they looked like this or like this. These are the ones we did in class. But I want you to know that there's other possibilities out there. Like this one. Your answer, ours could have been 4 to the n plus 1. You can add 1 to the exponent, and that's kind of tricky. Or you could even have one that's n to the n, which is kind of crazy. So that would be like 1 to the 1, 2 to the 2, where you're changing both of them. So I just want to let you know that even though I didn't work every single one of these in class, on your homework tonight, you're going to see one of each of these. So this homework is one of the most important homeworks of the whole year. I need you to do your homework tonight. Of all your homeworks, please do this one. I'm glad you like my font. Okie dokie.